Hello, MAB Elementary. This is Astronomy with Mr. T. Yesterday, we looked at the birth and death of stars. Stellar nucleosynthesis is the word the scientists use for that. And we learned how stars go through a life cycle and they form in the nebula. You remember? I showed you some pictures of nebula. Here's one right here. That's particularly dramatic. And there, inside that nebula, which is a cloud of gas and dust, mostly hydrogen that comes from the Big Bang. And those clouds of gas and dust begin to spin. And the particles in those nebula accrete together. Gravity pulls the particles together. And they form basically clumps of matter in the nebula. And those clumps continue to accrete, gathering in more and more gas, more and more hydrogen, and some helium. And that builds into a mass, a huge mass of gas, hydrogen atoms mainly, and dust. And what happens is, as that core gets tighter and tighter, denser and denser in terms of its mass, it gets hotter and hotter. And that heat, as it builds up, eventually, over thousands of years, it rises to 15 million degrees centigrade. And at that temperature, nuclear fusion happens. And that means that the atoms of hydrogen start to fuse together. And over time, they form helium, and then the heavier, elements like magnesium and calcium and carbon, and that's how the stars come to life and how they burn over time, and eventually they die. And so, what our lesson is today is the lesson on the classification of stars. We in Montessori science always talk about how the human mind classifies things. It likes to put things in categories. When you see a lot of information, your mind automatically begins to classify it, to group it together, to put it and store it in your brain in ways that make sense and have order. And we do that not just with science, we do that with words. When we look at words, we classify them by the function of the words that they do. When we classify zoological animals, we look at the genus and the species and the family and the order. So that's what our mind does naturally, and that's what science does. Astronomy is a science. And so astronomers classify stars. And they're these stars that are born in the nebula. Well, let's talk about our sun just for a minute. I'm going to go into a much more detailed lesson on our sun in a couple weeks' time. But our sun is a yellow star. It'll burn about 10 billion years. And then at that point in time, it'll swell into what we call a red giant. And then it'll collapse into a white dwarf, which will be only about the size of the Earth, and then it'll burn out. Another kind of star in the classification are the red giants. In the final stages, our sun may explode into a supernova, hurling dust and elements millions of miles into space. That's the death of the stars, the death of our sun. And those heavy elements and the hydrogen and that is thrust into space by a supernova is the star stuff. The remains after a supernova are maybe a neutron star. And a neutron star is very small, maybe just 10 miles in diameter, but super dense mass of elements. Neutron stars might continue to collapse over millions of years, and that would form a black hole. The core center of many of the galaxies that we see in the universe are a black hole. So stars range in size from neutron stars, which are small, 20 kilometers, about 12 miles in diameter, to the diameter of the supergiants. And a supergiant can have a diameter, think about this is a line through the center of the sphere of the supergiant. That diameter may be huge, and the circumference of the supergiants might be the size of Jupiter's orbit around the sun. Very hard to conceptualize a star with a circumference. That's the distance around the sphere of the sun. That's as large as the diameter, as the orbit of Jupiter around our sun. So, I want to talk to you a little bit now about the types of stars. Astronomers classify stars by type as the main sequence stars. And these are 90% of the stars that we can see in the universe around us, and it includes our sun. These are main sequence stars. Then astronomers can see the giants and the supergiants. And those are main sequence stars that have continued to grow over billions of years, increase in size, and eventually, as I noted just now, eventually they die, maybe as a supernova, and then collapsing into a neutron star and maybe a black hole. And then scientists can also see out there the white dwarfs, and these are very faint stars that are left over when a giant runs out of fuel and shrinks down. White stars and neutron stars are pretty much the same, the white dwarfs. Another way that we classify stars as astronomers, and that's what you guys are becoming as you continue your study of the cosmos and with Mr. T, we classify stars by brightness. Well, each stars give off different amounts of light depending upon their size and their temperature, and then of course their distance from where we're looking at them, from Earth. They seem brighter or less bright, but scientists measure them by their brightness depending upon their size and their temperature. We also classify stars by surface temperature. The coolest stars out there are about 3,000 degrees centigrade, but the hottest ones might be 50,000 degrees centigrade. And astronomers also classify stars by their color. And the coolest of the stars are the red stars, and the hottest of the stars are the blue stars. I'll tell you a little bit about in their searching around the universe for, as they research stars, how scientists have discovered one particularly old star. It's 13.3 billion years old. Remember, our sun's about 4.6 billion years old, and we expect it to burn for another for up to 10 billion years. So it's got about 5.4 billion years of life yet to go. This star, as scientists have found, they've aged it at 3.3 billion years old, and it's called a carbon-enhanced star. And that's because it's composed of many heavy elements, carbon and manganese and calcium, in addition to the hydrogen and helium that makes up most of our sun, our star. So this kind of star, this old star, the carbon-enhanced star, is about 20% heavy elements, whereas our sun's only about 2% at this stage of its lifestyle, of its life. This old star is huge. It's getting to the end of its life, and it's likely to only live a few million years more. And then it probably will explode into a supernova, sending the heavy elements of its composition out in the cosmos to form new galaxies and new planets. That's the star stuff that everything in the universe is made out of, including living things like you and me. We're star stuff. Pretty amazing, isn't it? The last thing I want to tell you about are global clusters. There's a global cluster out there in our Milky Way galaxy, and I'm going to show you some pictures, and I'll post them with this lesson from my fabulous book of astronomy pictures that I have, and I'll show you some of the clusters. Well, you can think of clusters like, if you have little snow globes that you buy, maybe when you go to visit a tourist site or something, you shake it and you see all of those little glitters of sparkling flakes flying around. Well, that's what a global cluster a globular cluster of stars looks like. And some of them have maybe 100,000 stars, 25,000 light years away from Earth, packed very, very tightly together, only 150 light years across. And they're so crowded together, these stars and these globular clusters, that they can slam into each other and then form a blue straggler star. Some of the brightest stars in the clusters, in the globular clusters, are the red ancient giants that have cooled down, and the hottest ones are the blue-white stars. So I'll show you some pictures attached to this video of globular clusters and some of the other really cool types of stars that I've talked about in this lesson as astronomers classify stars. So I hope you've enjoyed this astronomy lesson on classification of stars. And I look forward to seeing you again soon. And I hope you enjoy the pictures. This is Mr. T signing out.